So we should know how to factor already, and there's many factoring methods, right? What was the first type of factoring that we've ever learned? Anybody? Well, factoring, okay, how about that? Let's begin with the definition of factoring. What is factoring? It's reverse distributive property. It's when you have the answer and you want the multiplication question. So if I told you, like, give me the factors of 6, right? Give me a pair of factors of 6. Well, that would be 2 and 3. Yeah, 3 times 2, 2 and 3, right? So factoring is kind of like you having the answer and wanting the multiplication problem, all right? So obviously, we're not working with 6, 2, and 3, but let's look at a polynomial maybe. So if I said factor 3x minus 9, right? The very first type of factoring that we learned was factoring out the GCF, the greatest common factor. So in this case, what is in common in both terms in that binomial? A 3, right? So notice I put parentheses right below the original, and I pulled out that common multiple of 3. So if I think 3 times what would get me back to the original 3x, that would be 3 times 1x. You could just put x. And then 3 times what will get me back to a negative 9 or a minus 9? That'll be a negative 3. And that's what factoring is all about, right? It's like if you had the answer, but you wanted the distributive property problem, the multiplication problem that gives you that answer. So factoring is just a reverse distributive property, okay? Of course, it gets a little more interesting. If I take a look at, let's say, a polynomial, such as, let's say, 6x to the third minus 18x plus 8. Let's make that an x to the fifth and 8x to the second. I don't know. So what would the GCF right there be? 2x to the second. Exactly right. So when you're looking at 6 and 18, you're probably thinking, oh, I could pull out a 6, but you can't pull out a multiple of 6 from 8. So when you're looking at the multiples, yeah, for sure, the 2. And when you look at the x's, there's 3 x's here, 5 there, 2 there. The maximum amount of x's that you could pull out of all 3 of them would be 2 of them. So 2x squared is your GCF. Your GCF is 2x squared. So if you do pull out that GCF, what would be left over on the inside? 3x, and then the middle term? Minus what? Again, remember 2 times negative what will give you a negative 18? 9. Okay, and then how about the x squared times how many more x's do I need to get to 5? X to the 3, right? And how about that last term over here? That's just going to be a 4, positive 4. And that's what factoring is all about. Well, technically, that's what factoring out a GCF is all about. Now, there's many other factoring methods. Do we understand factoring out the GCF? That's a very essential part. So we need to know how to do pulling out the GCF. This top one up here, like if this would have been instead of an 8, a 24, then I would have been able to pull out a 6, right? Because 6 times 3, and if this were a 24, 6 times 4. So you always want to pull out the greatest common factor, GCF. Now, we also factored quadratic trinomials, such as this one, x squared minus 2x minus 8. Now, this is the easier type of factoring because the a value is 1. Okay, so when your a value is 1, by the way, a standard form quadratic trinomial, your a value is in front of the x squared, the b value is in front of the x, and the c value is the constant without a variable. Okay, and when you're factoring out a quadratic trinomial that has no number in the front, that means your a value is 1. That means that you could set this answer format up, the factored form format, parenthesis xx. Why could I set this up? Because x times x is x squared, right? Now, if I had like a 12 right here in front, then I wouldn't be able to do x times x because I have a 12. If I had a 12, then I might have a 3 right here and a 4 right there, or maybe backwards a 4 here and a 3 there, or maybe a 2 and a 6, or a 1 and a 12. It gets a lot more complicated if your a value is not 1. So when it is 1, set this up. Then after that, you simply think what times what is the c value that if you combine together is the b value. And I always say make a list. So I'm going to make a list of the multiples of negative 8, like negative 1 times 8, like negative 2 times 4, like negative 3 doesn't work, and that's it. There's only two possible ways of multiplying numbers together to give you the answer negative 8. But then again, you could change the signs if you need to. So the question is, which pair of numbers combines together to give me the b value, which is negative 2? There you go, 2 times negative 4. If I just add the negative 2 and the positive 4, I get the answer positive 2, and we know we want a negative 2, but we do have the right number, just the wrong sign, so we have the right numbers, just the wrong signs, so you have to change them to a positive 2 and a negative 4. So let's just plug that in, positive 2, negative 4, we are done. Now let's say you ever do this factoring method and you're not too sure if you did it right, you could always distribute, combine like terms in the middle, and it should give you what you started with. Any questions? How about you guys try this one? X squared minus 12x plus 24. Totally separate problem. Factor it. So that's what you want it to look like, two parentheses, right, with a binomial in each. Now, because your a value is 1, what should we put right here and right here? X's, right? Okay. Now, what's the thought process? Anybody help me out here? What's the next step after setting that up? Thinking of the multiples of your c value, which in this case is what? 24. So let's make a list of the multiples of 24. I always start with 1, right? Like 1 times 24. Or 2 times what? 12. Or 3 times what? 8. Or 4 times what? 6. Or 5 times, oh, that doesn't work. Okay, so forget about that one, right? So there are all your multiples of positive 24, right? Now, which pair of numbers, if I start adding them, will give me a negative 12? This gives me 25. This gives me 14. This gives me 11. This gives me 10. So what do I put right here? Which pair of numbers work? None of them. So this is a situation where it's not factorable. That simply means that you're not able to factor it. Not factorable. And that does happen at times. And I think on the quizzes assignment, I ask you to just type in NF. Not factorable. Okay? Cool? All right. So what if this problem, how about now, I just changed the middle value to a negative 14, and now it is factorable. So you guys tell me, what is the correct factorization of this quadratic trinomial? X, negative 2, x, negative 12. Thank you so much. That is awesome. You got it. Again, the thought process. How do you do this? You set this up first, the x and the x. And then you think of the multiples of your c value. So make a list. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Out of those pairs of numbers, which combine to give you the middle value negative 14? That's 2 and 12. That gives you positive 14, but we know we want a negative 14. So we have the right numbers, just the wrong signs. So you would change that to a negative, change that to a negative, and that's how we get the negative 2 and the negative 12 that you guys already gave me from the start. I just wanted to explain it. Are we cool with that? All right, so what type of factorings do we know or have we reviewed so far? Pulling out the GCF and also factoring quadratic trinomials when your a value is 1. Now, I have a situation where it requires both. Let's say you had a 2x squared minus 2x minus 12. Everybody copy that down. Always start with trying to pull out the GCF. What's the GCF here, guys? 2. Okay, we're going to pull out that 2. What's going to be left on the inside? X squared minus 1x minus 6, right? Now, if you look at the inside, now you do have a quadratic trinomial where your a value is 1. So now you could try to continue factoring. You might not be able to, but you try it. So let's think, what times what is our c value negative 6? Let me make a list. Negative 1 times 6, negative 2 times 3, and that's it. Those are the only two ways of getting negative 6 besides changing signs. So if I look at these two numbers, if I add those together, That'll give me a positive 1, but I want it to be a negative 1, but at least I have the 1. So I have the right numbers, just the wrong signs. So make that a positive 2 and a negative 3. Pop that in, positive 2, negative 3. Don't forget about the outside 2 that you had out here. Bring it down. And ladies and gentlemen, this is your completely factored form. You got to know how to do this. If you don't know how to do this, there's no way you're going to be able to pass chapter 8. You have to know how to factor. You got to be great, not just good. You got to be great at factoring to be able to pass section 8.1. All right? And there's still more. There's still other types of factoring that we need to review. Like, for example, we should be very comfortable factoring a quadratic trinomial that has an a value of 1, but what if it actually had a number? Everybody jot this one down. Obviously, the a value is not 1 anymore, so you cannot do this. You can't just jump right into that because x times x is not 14x squared. So you have to remember that old method that I showed you, the multi-step method. Does anybody remember the multi-step method of factoring a quadratic trinomial when the a value is not 1? Step 1 was, if you don't remember, please write this down, a times c. You guys remember that? What is a times c? We have 14 times negative 3. 14 times negative 3, that is negative 42, right? Okay, so the next step is to make a list of the multiples of negative 42 in this case, right? So let's make a list of the multiples. We have negative 1 times 42. We have negative 2 times 21. We have negative 3 times, anybody? 14. We have negative 4 doesn't work, negative 5 doesn't work, negative 6 times 7, right, is 42, negative 42. So those are all the possible ways of multiplying numbers to get negative 42. And now, I used to tell you which of these pair of numbers combines together the middle value 19. I'm still going to tell you that, but which pair of number works? None? Doesn't negative 2 and positive 21 work to give you positive 19? It does, right? So this is a pair of numbers I want. Now, in the past, I would say take these two pairs of numbers and rewrite your middle term as those two pairs of numbers so you could have 4 terms, so you could factor by grouping, which is another 4 steps in itself. Let's not do it that way. I also showed you a shortcut method. I hope you guys remember that. If you don't, that's what we want to use, the shortcut method. So jot this down. Step 3 is to set up this format, okay? AX with a number right here and a number over here. That's the setup for step 3, okay? So obviously, looking at the original quadratic trinomial, what is AX? What is AX? What is A? A is 14, B is 19, C is negative 3. So I am going to put a 14 with an X right here and a 14 with an X right there. Now this is technically wrong because I know that 14x times 14x is not 14x squared. It's a huge number with an x squared, right? But that's what step 3 is. And what about these number symbols right here? What numbers go right here? The numbers from step 2, the negative 2 and the 21, go right here. Okay? The negative 2 and the 21 go right here. And it doesn't matter which order you put it in, it still works out. So I'm going to put a negative 2 right here and a positive 21 right there. Are you with me? That is what we call step 3. Just plug it into your factored form answer format. Now this is the hardest the hardest type of factoring there is, but if you practice it, it's really not that bad. We are now on to the final step 4. And step 4, I'm going to say magically reduce. What I mean by reduce, it's not even a fraction. You can't really reduce, right? But I use the word reduce because it's kind of like reducing. Like I look at the first binomial. There's a 14 and a 2. What could I reduce by? And the reason why I'm saying reduce because I don't want you to confuse it with pulling out a GCF. It's kind of like pulling out a GCF. But right here, I'm just going to magically divide the whole entire first binomial by 2. Okay, I'm going to magically divide the first binomial by 2. So what is 14x divided by 2? 7x. What's 2 divided by 2? 1. Now what about the other binomial? What could I divide over here, but could I divide by 2? No. What's the greatest value I could divide by? 7. So if I divide both of them by 7, what's my binomial going to be? 2x plus 3. And believe it or not, we're done. This is your factored form answer format. Now let's say you're questioning yourself, you're not sure if this is the right factored form. You could distribute 7x times 2x is 14x squared. 7x times 3 is 21x. But negative 1 times 2x is negative 2x. And 21x take away 2x is the 19x that we have in the middle. And negative 1 times positive 3 is that negative 3. So we truly did factor this original quadratic trinomial that had the 14 as the a value down to this. Sound good? Yes. Okay. Is that it? Oh no, there's one more type of factoring, but it's super easy. Like, just because you have a number right here, don't jump right into these 4-step process, right? What do I mean by that? Let's say you had 4x squared plus 12x plus 9. Everybody should copy that down. Now some of us are going to see that 4, the a value is not 1, and people are going to be like, oh, I'm going to do step 1, multiply a times c. Take a moment and check and see if you have a perfect square term in the front and a perfect square term in the back. Possibly, if they are perfect square terms in the front and in the back, then maybe you could square root it and plug them right into your answer. Okay? Now, let's try that. If I square root 4x squared, what do I get? 8. The square root of 4 is? 2. And the square root of x squared is x, right? So the square root of 4x squared is 2x. So I'm going to put a 2x in the first part of each of those binomials. Now over here, I also have a perfect square number. So what's the square root of 9? 3. So put a 3 right there and a 3 right there. Now the question is, what symbols belong here? Is one positive and one negative? Are they both positive? Are they both negative? Well, if one's positive and one's negative, there would be no middle term. It would cancel it out. And not only that, it can't be a positive and a negative because a negative 3 times a positive 3 is not positive 9. So they're either both positives or both negatives. So what do you say? If the middle term's positive, what do you think these are? Both positive, right? So plus, plus. So this is your factored form answer, but you got to double check it, right? If you see perfect square numbers, you could jump right to your answer, but double check it. So let's double check. If I go 2x times 2x, I get the 4x squared. 2x times 3 is 6x. 3 times 2 is 6x. 6x plus 6x will give me that 12x, and 3 times 3 is 9. So I know I did this right. So this is what we call a perfect square quadratic trinomial. Perfect square quadratic trinomial. Now, it could get even easier than that because if you have a difference of two squares, like what if I had, instead of that, put a squiggly line right there, what if I had 4x squared minus 9? That's even easier than before. You still have a perfect square term in the front, you still have a perfect square term in the back, so you're still going to square root them. 2x, 2x, square root of 9 is 3. But because there's no middle term, and because it has to be a negative 9, then you put a positive and a negative, or a negative and a positive. The signs have to be different. That's all that matters. And that's your answer. Cool? And that pretty much covers all the different types of factoring that we're going to be using in section 8.1 tomorrow. All right, so today you've just witnessed me go through all the different factoring methods. Now you got to demonstrate that you actually know it. We have an assignment on quizzes on Google Classroom today. It's 15 questions long. There are no videos. It's just to see if you guys know this stuff or not. It will go into your grade. So let's do that. Let's work on it. Ask for help if you need to. It's going to go into your homework grade. Don't waste time. Go for it.